Tonight, the moon enters into the third quarter, which means we're now in the deep sky astro portion of the lunar cycle. It'll last for about 10 more days. What you're seeing here is a view of Messier 3. Note the shutter speed if you can see it. It's 2 flood, equivalent to about a 2-inch telescope. And the sensitivity is at 42 decibels. So combined, 2 flood and 42 decibel means we're getting about a 2-inch view. Now what astonishes me about this, the sky is still visibly blue. It'll be at least another half an hour before we approximate sky dark. We're advancing very quickly towards Midsummer's Eve, which means it won't really means the nights are going to be very short and very late in the arrival. So, however, there will be some very spectacular studies to be able to view and image over the evenings, beginning with Messier 5, arrival to M3 and M13 for a most spectacular globular cluster visible from the northern hemisphere. So there is our look. We're now up to date in time. Seeing conditions seem quite good. I will show you once again various settings that I am now using that I kind of honed in on in terms of doing general real-time imaging of deep sky studies using the Revolution 2 system. And I will do that, in about another 15 minutes or so as the sky gets a little darker. We'll catch you later. And for you, it'll be with just a few seconds. For me, maybe 10 or 15 minutes. Well, these are the last settings I set up for picture adjust. The brightness is at 100, the contrast at 51, sharpness 12, hue 62, and color gain 124. Basically, most stuff is in the middle of the bar with a couple of advanced settings for contrast and sharpness. And there continues to be our view of Messier 5 in the background. The sky still has color in it, so we have not achieved sky dark as of yet. Okay, the camera just shut down on me. I'm not sure whether it was recording or not, but we now have our shutter setting for tonight, which is 128 flood and 42 decibels of gain or sensitivity on the CCD imager. That's a pretty sharp view of Messier 5. We'll stay with this setting. I'm hoping we'll be able to see some galaxies to magnitude 15. As well as other deep sky studies of the evening that I'll be pulling out of the Astro.Geekjoy Deep Sky Atlas. So I'm going to give it a chance. The sky's still got a hint of blue to it. We haven't achieved sky dark, but I think within the next 15 minutes or so, I think we can call it sky dark and proceed with select studies out of the Astro.Geekjoy Deep Sky Atlas. Well, folks, it's about 5 minutes after 10. I would call this sky dark, at least in the sky middle third. Let's start with Messier 5, globular cluster in Serpens, magnitude 5.7. Quite large, 19.9 arc minutes in size. 24,500 light years distant. Its brightest stars are probably of the 12th magnitude. And it pretty much makes itself very present on the screen. So we'll move on now. The scope will probably have to do an equatorial flip, but we'll see about that. And then we'll move on to some NGC galaxies. Our first galaxy of the night is NGC 5248. It's a galaxy in Boötes, magnitude 10.3, fairly large. Nearly face-on, 5.9 by 4.5 arc minutes, spiral of a Bard class, 49 million light years distant. It's pretty obvious on the screen. There's some a sense of spiralicity outside the core. And you can see it right on the border between in the high and low contrast areas of the screen. Something I always like to do is do a next. There's another galaxy very nearby, magnitude 12.9, 1.6 by 1.2 arc minutes. This one's very distant, 344 million light years distant. Scope made a bit of a jump to go to it. I'll give you more data on it as it assembles on the screen. That's NGC 5249. NGC 5249 is also a galaxy in Bootes, but its magnitude 12.9, 1.6 by 1.2 arc minutes. It's a lenticular spiral, so it's a class O spiral, 344 million light years distant. Given its size and distance, it is undoubtedly larger than the great galaxy in Andromeda, which means it's a super average size galaxy. I believe you can see the core right at the tip of my finger. Bright core with a sense of spiralicity about it. Magnitude 12.9, it's probably a decent view in a 12-inch scope. Our next study is NGC 5363, galaxy in Virgo. Magnitude 10.1, 4.6 by 3.1 arc minutes. It's a spiral with an active core, 50 million light years distant. You can see it looks a little bit irregular right here. There's a well-defined section in the upper part of the screen and a more diffuse area down below. You can see extensions going off to the directions. The stars are looking very nice on the screen, nothing particularly bloated. Yeah. 5363, and I believe, let's see, it is rated as a 12-inch study. Actually, 5363? Yeah, no, it should give a good view in a 10-inch scope. Not bad. Let's see if I just skip to the next study, it's a galaxy in Virgo. 5364, as long as it doesn't do anything strange. Let's see if we can go to it as an adventitious study. Well, it was very close. Neighboring galaxy, not much of a leap there. As it forms on the screen, I'll tell you more about it. NGC 5364. Let's dial it in. Oh, it looks fairly diffuse, doesn't it? NGC 5364 is a galaxy in Virgo. It's also 5317, magnitude 10.5, largish, 6.1 by 4.2 arc minutes. It's a spiral with a bar, 56 million light years distant. But it looks like it spreads out its light, doesn't have a very bright core. Gives a largish view on the screen. See what the next one is. No, the next galaxy is 5365, is in Centaurus, so let's shut this screen imager down and go to the next one in our study list. Well, not a galaxy here, as you can tell. NGC 5634 is a globular cluster in Virgo. Fairly faint, so it gives us an opportunity to see if we get any stellar resolution. And looking at the screen, I'd say we are. It's magnitude 9.5, fairly small, 4.9 arc minutes. It's not a particularly dense. There's a scale for globular clusters. I think they go 1 to 12. This is a 4. 82,000 light years distant, which accounts for its magnitude. NGC 5634. Brightish core with a sense of resolution. And basically this one should resolve through a 12-inch telescope. Right now our settings are pretty much that of a 16 to an 18-inch scope. And of course sky limited. We are definitely into sky dark now. So we are getting a pretty good view. I am shifting around a little bit, but I'm not seeing too many problems with presentation on the screen. Even though I'm not sitting on my pillow because we're only operating at 128 flood. So there we have it. A nice globular cluster, 5634. Our next study is an adventitious study. NGC 5635 is a galaxy in Boötes. Let's get some data on it. 5635 as it forms on the screen. Looks like it's taking form right about here at the tip of my finger. 5635, I'm sorry, galaxy in Boötes, magnitude 12.5. It's a 2-to-1 aspect ratio, 2.3 by 1.1 arc minutes, some 199 million light years distant. So it pretty much, it's a spiral with a lowercase b. As I said, 199 million light years distant. It's probably about the size of Messier 31. 12.5 magnitude. Let's see if there's another adventitious galaxy. I want to get a faint one. 5637 is magnitude 13.8. I'm going to go ahead and make a run to it. Okay, galaxy NGC 5637, a galaxy in Boötes, forming right there on the screen. Magnitude 13.8, smallish, 0.9 by 0.5 arc minutes. A spiral of lowercase CD class, 238 million light years distant. And pretty present on the screen too. I'm sure we can go another magnitude deeper and still be able to tech things. I'm skipping around. Oh, here's a galaxy in Boötes, 14.6, largish. Let's go there next. It's galaxy NGC 5639A. Uh-oh, looks like it wants to pole flip, so I'm going to shut the camera down. Well, I hate to say this about the mount, but it just basically went a little bit insane and started spinning awkwardly off in no direction that made any sense whatsoever. So I had to interrupt the drive, repark it in a counterweight down position, and then re-enter NGC 5639A, the galaxy in Boötes. Its magnitude is 14.6, 1.4 by 0.9 arc minutes, 159 million light years distant. I think it's pretty clear that it's located next to this star. It's a pretty decent view for an almost 15th magnitude galaxy. Even at 128 flood, I'm quite impressed. I imagine we can probably go another magnitude, certainly 15.5 magnitude deeper. So hey, there's at 128 flood. Now I have been able to image all 5 stars of Stephan's quintet. It wasn't a challenge, but there's a 16.5 magnitude neighbor I was also able to capture last fall. I'm not sure if my settings were 128 flood or 256. There has been refinement since then. But let's see if there's a B galaxy as well. It's magnitude 17. It's very faint, 924 million light years distant. Whoa! That would be the most distant galaxy imaged. It must be very close to this galaxy here. I'm going to go ahead and go to it, but I don't expect much of a change. I saw the star shift right there. All right, so I'm just going to allow this to be captured, and then maybe when we look at the screen tomorrow and you get to view this on our YouTube channel, maybe you'll be able to pick out that very faint 17th magnitude galaxy, which is NGC 5639b. I would be blown away by it, but I am seeing something right about there, but it's right on the limits of visibility. But a 17th magnitude galaxy would be quite astonishing. Anyway, does seem to be present, however. It's just so miraculous to be able to use something like a Rev2 imager with longer exposure times and multiple image captures, because basically it's turned this 6-inch refractor into something that can easily be the equivalent of a 24-inch. It doesn't have the resolution, of course. At best, if I took out the focal reducer, I'd get about 1.1 arc seconds of resolution, given the spacing of the CMOS sensors on the imager itself. Right now we're operating at 75x, not 150. We're getting about a little more than 2.2 arc seconds of resolution. But boy, I do have a real sense of that 17th magnitude galaxy right about there. Let's go back to our observing schedule, however. But that was a really nice find. NGC 5639b galaxy. Okay, what we have here is a deep south globular cluster in Hydra. NGC 5694. Faintish, magnitude 10.2. Smallish, 3.3 arc, 0.6 arc minutes. Its brightest stars are magnitude 15.5. It's a class 7, which means it's probably a little more diffuse than most. Some 111,000 light years distant. I think the cluster is pretty well established right here. The core is brilliant. There might be some faint outer stars that could be resolved. And that would make sense, because I would expect stars to about magnitude 16 to be resolved. This is a 10.2, and it pretty much demonstrates the rule that the brightest stars are roughly 6 magnitudes fainter than the cluster as a whole. So there's our look at a deep, deep south globular cluster, magnitude 10.2. I'd like to point out that globular clusters are very interesting, because I don't think we could image a 12th magnitude globular cluster and see it as a globular cluster. That would be interesting if we could turn one up that was of the fainter. But we see 16th magnitude galaxies readily, but I don't think we'd see any 16th magnitude globular clusters as globular clusters. Something to explore as we go on, but most of the globular clusters range from about magnitude 6 to a magnitude 10.5, so we may come across very few instances. As a galaxy in Boötes, we can go adventitious. That's magnitude 12.8, doesn't really push very far. Another one in Boötes, 13.7 in Boötes. I'd like to get something around magnitude 15. There's a galaxy in, it's very small, magnitude 15.7. Should be fun. Let's see if we can turn it up. Off with the camera. Okay, this is NGC 5699, an adventitious galaxy in Boötes, which means basically I'm just pressing the next button and looking for interesting studies. This one is also known as 5706. It's magnitude 15.7, and like an earlier one, pushes us almost to 1 billion light years distant in space. This one's small, 0.3 by 0.3 arc minutes, and it is an elliptical, which means it should be highly condensed. Now I'm seeing one galaxy here, another galaxy there. I cannot be sure that we're actually seeing this nearly 1 billion light year distant galaxy on the screen. But right where we've been seeing things all along, there is a galaxy. I am astonished. There's no way to demonstrate and prove that we're actually seeing that galaxy except to step around and see if there's another galaxy in the region or do some research online. If I press the next button, we go to 5700. It's a magnitude 15.2. Let's see if we jump very far to go to it. We do. This one is overhead and maybe partially blocked by the roof tride. So I don't expect to be able to see NGC 5700 given its faintness. But let's let the screen develop while I look up the next actual plotted study for tonight, which is 5824. So this we kicked off with 5694. Now we're up to 5700. 5824 should be our next scheduled study, a 10-inch galaxy. 58. So I don't know. We'll look at the screen. I am kind of seeing something faint right about there. And this is fantastic. This is the faintest galaxy I've ever seen with a 6-inch scope at the eyepiece under decent conditions, was typically around magnitude 12 to 12.5. This is just astonishing to be able to use this technology and go so deep. 1 billion light years in space? Mind-boggling. Alright, it's pretty clear what our next study is, but it's deep, deep south. We're going full tilt with the scope. This is NGC 5824, a globular cluster in Lupus. It's also known as NGC 5834. It's brighter than some of the ones we've seen, the 10th night. This is 9.1, 6.2 arc minutes in size. Its brightest stars are 15.5. It's 102,000 light years distant, and it is a highly condensed globular cluster, a class 1 of 12. And you can see it right there. Core is highly condensed. We're only resolving a few of the outside stars. The brightest ones in it, as I said, are 15.5 magnitude, and we're seeing a sprinkling of the peripheral 15th and 16th magnitude stars in this cluster. I am very impressed, especially going so full tilt. This is a very good night of sky transparency. It's hard for me to tell for sure because I got bright lights in my eyes, but I am very impressed with some of the views. Let's do an advantageous. Let's go to F5825. It's a galaxy in Boötes, 13.8. Let's skip that one. Ooh, that one was kind of interesting because it was very distant. 13.9 in Draco. Here's a 5825. That looked interesting because it was so distant and was so bright. So the globular cluster was 5824. Let's go to 5825. Let's turn off the camera for a second here. Okay, what attracted me to NGC 5825 Galaxy in Boötes, also known as NGC 5778, magnitude 13.8, is its distance, 794 million light years. It's 1.2 by 0.9. It's probably a galaxy some 300,000 light years across, twice the size of the Andromeda galaxy, packed with stars because it's an elliptical, which means most of its cold dark matter has been converted into stars. So unlike spiral galaxies, this particular galaxy, wherever one it is, because there are several galaxies on the screen. I'm seeing one right here. Seems a little faintish for magnitude 13.8, but it probably is the galaxy. There are several galaxies on the screen. Notice how consistently well placed things have been tonight. I took a little time to make absolutely sure the tripod was as level as possible and then redid all my stellar alignments both to the eastern and the western part of the sky, and I'm very pleased with the outcomes. But yeah, that's probably our galaxy right there. Magnitude 13.8, 794 million light years distant. An elliptical galaxy with much in the way of stellar conversion. Most of these elliptical galaxies, by the way, are probably the result of collisions between spiral galaxies, which basically cause the cold dark matter of star formation to rapidly condense into new, very bright stars. So here's our view of another adventitious galaxy. I'm going to skip through them. There's a 5827, that's magnitude 13. I want to go for something faint. 5828, magnitude 14.3, very small. Let's go ahead and make a leap to that just for the heck of it. And then I'll go back to my scheduled observing list for tonight. Watch as we... Nope, we're not going to get much of a view of this because we are kind of looking through the roof again, although only part of the aperture has been blocked by the roof section. So let's watch it as it forms, 5828b. I see the galaxy. I see a galaxy right here on the screen at the tip of my, right at the tip of my finger. 5828b, galaxy in Boötes, 14.3, tiny, 0.3 by 0.2 arc minutes, spiral with lowercase b, 192 million light years distant. Zowie. Okay, what you're seeing formulating here is either a dense open cluster or a very sparse globular cluster. In fact, it is a globular cluster, NGC 5897, a globular cluster in Libra, magnitude 8.4, largish, 8.7 arc minutes. The brightest stars are magnitude 13.3. And yes, it is diffuse. It's a class 11 out of 12, 4,100 light years distant. I imagine this baby, as pretty as she is, would not be as pretty as Messier 11, excuse me, the wild duck cluster. So this is pretty diffuse, but it is a globular cluster, rapidly being picked apart by the tidal forces of our own galaxy. Given its distance of 41,000 light years, and it's probably about 30 degrees off the axis of the center of the galaxy, it's probably maybe 15 to 20,000 light years away from the great black hole at the maw of the galaxy. But you gotta look at those stars. They are very pretty, and the brightest of them are magnitude 13.3. Very nice. I'll do an adventitious on this. There's a galaxy in Libra, 5898. Let's go ahead and take a look at it. And it's not too far away. We'll let it form while I look up some data on it. 5898. I do rather enjoy this finding things that aren't necessarily on my observing list, and the Gemini 2 software is very helpful in that regard by allowing you to step through. So while I'm looking up this data, has anybody noticed where that galaxy is located on the screen? Frankly, I see a couple of them up there. NGC 5898 is a galaxy in Libra, magnitude 11.4, 2.6 by 2.3 arc minutes. It's an elliptical 1, which means it's a little more oblate than a pure spherical elliptical. 95 million light years distant, smaller than the Andromeda galaxy, I would suspect, in terms of real absolute size. There is our view. I suspect it's this baby right here, only because it's a bit more diffuse than the stars around it, and I can see some extensions of nebulosity going off into the distance. So let's go back to our observing list for tonight, and we only got 2 bars left on the camera. What you're seeing on the screen is NGC 5846, a galaxy in Virgo. Brightish, magnitude 10, 4 by 3.7 arc minutes. It is an oblate elliptical, an EO-class galaxy, 79 million light years distant. You can see it almost looks globular-esque, except there is no sense of resolution about it, although there might be some pixelated resolution visible in the way the galaxy presents itself. If I do a skip, a 5846, let's take a look at that. It probably is very close. If not, yeah, it's very close. So we did make a slight shift there. Very, very slight shift to Galaxy 5846A. I'm not going to give you data on it, but it was very interesting to watch the screen shift. We are going to exit once again with a nice view, hopefully, of Messier 5, because I've pretty much completed the list for tonight. And it's nice to be back into the night sky because we've had some weather and we've had some moon, and I have been away. And this gives the beginning of another possibly 10-day cycle of deep sky observing. So we are going to revisit Messier 5 under far more encouraging conditions to begin with, but frankly, it wasn't bad. The initial view. Well, let's watch the cluster form on the screen. Intensely brilliant core. Stars are a little bit messed up because the scope is finalizing its motion. I got 2 bars left. That is not a particularly pretty view of Messier 5. We're being overwhelmed, but let's give it the 20 seconds or so that it needs to finalize the image quality and watch it as it resolves itself on the screen. Stars are starting to look like stars. Core is completely overwhelming. If I were imaging this in color, you'd see a big hole in the middle, because when you go to color mode on the Rev 2 imager, when it's too bright, it basically masks it out unless I can find another setting. Maybe I'll do a little experiment with color mode before we exit out, but in case I run out of battery or something, let's carpe noctem on this view of Messier 5, and once again I will give you these data on it, because it's always nice to know when you're doing stargazing some of the technical aspects of what you're looking at. So we got a Messier 5. It's a globular cluster in Serpens, the serpent. Magnitude 5.7, largest, almost 20 arc minutes, 19.9, 24,500 light years distant. Now it doesn't give us a density value like it has others, but I would estimate it's probably a class 3 or class 4 globular cluster, with class 1 being the densest. And that is quite a good view. I'm going to go ahead and play with settings and put on color. And let's see if there's any color in this baby. So, if I don't get any good results, or if the battery runs out, carpe noctem. Okay, to set up color modality in the Rev 2, I've discovered you just shift it from night to day mode. And the result you're seeing here, and it hasn't masked out the core. I've seen it mask out the core of bright stars, but apparently we haven't completely overwhelmed the CCD imager. This is the view of Messier 5 in color mode. What I'm going to do, however, is plug in a galaxy. There's a brightish galaxy not too far away. It's 5248. It's a 10-inch study, which means it should be pretty good. 5248. Hopefully we won't have to leap too far. Let's see if we get any sense of color when we go to the galaxy. Color mode really works well with nebulae, planetary nebulae, and basically nebulae of the class of Lagoon Nebula, for instance. Let's see. Hopefully she won't pole flip on it, equatorial flip. And hopefully she won't be blocked by the roof try. Ah, no, we got full aperture now. So, this is going to be our last study for the evening. It's NGC 5248. However, I've set the Rev 2 up for day mode, which means if there's any hint of color in a 10th magnitude galaxy, NGC 5248, we might get a look at it. Now I'm seeing something a little bit purplish on the screen. Oh wow, look at that beautiful view of the spiralicity of the galaxy. Wow, look at those spiral arms. I don't think we got that view earlier. I think it hinted at that. Now remember, we were imaging NGC 5248 just before sky dark. I'm going to give the data again on NGC 5248 because that's a very nice view. I'm looking it up. Enjoy while I do so. Look at those spiral arms. Wow. Okay, NGC 5258 is a galaxy in Virgo. Magnitude, I thought it was 48. I think I've screwed this up. Let me go to 48. I must have plugged in the wrong value. Okay, NGC 5248. 5240, not a G. 48. Enter. Alright, all that meant is you got a chance to look at this beautiful face-on spiral a little bit longer than you might have been able to. 5248 is a galaxy in Boötes, magnitude 10.3, 5.9 by 4.5 arc minutes. It's a spiral with a central bar and lowercase bc, 49 million light years distant. And let's see, are we getting any sense of color? That's a gorgeous view. Ah. Large, bright, barred spiral, 49 million light years distant. And with that, we shall say carpe noctem, and then hasta la vista. Hopefully we'll have some other decent nights between now and the next lunacy. We've got 10 days to accomplish it. Carpe noctem.